Finding the standard deviation of this short list of numbers, we have x bar equals 3 plus 1 plus 6, and we'll divide that by 3, which is 10 divided by 3, gives us an average of 3.3. So we'll go back and have 3 minus 3.3, quantity squared, and then the quantity squared of 1 minus 3.3, and plus the quantity squared of 6 minus 3.3. All of that over the number of numbers minus 1, which is going to be 2, and then we need a square root symbol around all of it. Okay, so in the first set of parentheses, 3 minus 3.3, and then square that. 3 minus 3.3, and square that, it should be 0.09. And we're going to add to that 1 minus 3.3, and then square that, which should be 5.29. And then 6 minus 3.3, square that, is 7.29. All of that over 2 and underneath the square root sign. So 0.09 plus 5.29 plus 7.29 should be 12.67, and divide that by 2 to get 6.335, and the square root is 2.5. Are we all in agreement on the standard deviation?
Yes.
2.5. Okay, so here's what you do with that next. You'll need a normal curve, kind of looks like a bell, and you need your standard deviations on either side. Remember, what number is always in the middle? 0. Then we go 1, 2, 3, and then back, -1, -2, -3. The average from our list of numbers came out to be 3.3, so we will put that here, 3.3. The standard deviation of that list of numbers came out to be 2.5. So from the 3.3, we are going to add 2.5 as we go to the right. So 3 plus 3, or 3.3 plus 2.5 is 5.8. And then add 2.5 again to get 8.3, and 2.5 again to get 10.8. The 2.5 is the standard deviation. And then we go back to average, 3.3, go to the left and subtract. So 3.3 minus 2.5 is 0.8. And then 0.8 minus 2.5 is -1.7. And then we have another minus 2.5, which gives us a -4.2. Now keep in mind, these are all separate numbers here. It's kind of difficult for me to write small on this. But we've just lined out your standard deviations with the actual numbers from the list that we used to find the standard deviation. So we only had 3 numbers in the list, so this isn't going to come out to be exactly normal, but it will be a good starting point. Let's go ahead and fill in the columns on the right and then the left. And if we go back to our list, we had a 3 in there to start with. In fact, we'll just write them all down, 3, 1, and 6. On your standard deviations, where should the 3 be placed? Look at your numbers here. Where does a 3 fall in at? Yeah, so it should go right in here. And then a 1, where does the 1 go? Between -1 and -2, yes, down in there. And then where does the 6 go?
Between 2 and 3.
Between 2, yeah, between 1 and 2. And if you remember back to your percentages for this, the middle 2 here should contain 68% of your data if it's approximately normal or close to it. Well, only one of our numbers shows up in there, and 1 out of 3 is 33%, so that's off. Over here, if we extend out this way, you were supposed to have 95% of your data fall in there. Well, clearly we have 100% of our data because the 1, 3, and the 6 all fall into that spot there. And of course, if you go out to this area, we have 99.7%. We have more than that inside of just the 95%. So this list of numbers is not approximately normal, it's skewed.